So those are really the very basics of just getting a quality image.
You can move the focus point, which is on the right, that double yellows.
There.
You can change the
We start
frequency.
at 12 vectors. So that all looks in place. And the other thing you'll notice, on every probe, there's an indication on the probe of which side is left and which side is right. And that will help you as you're watching the screen to help you orient what you're looking at. And when you're first starting this, when you're first getting started doing this, what I would suggest is you pick an area, in any area that you're going to scan, pick a very easy to identify anatomical landmark that will orient you to what you're looking at. Because when you first start, it just looks like a bunch of gray mush, and you're not really sure what you're looking at. And it also is a dynamic, and I just put it here, the anatomical landmark I like to start with is the pisiform bone. And so this is, the purpose of this is really just to kind of orient yourself to what the structures look like. And so the bone is the easiest to see. This is the pisiform bone here. It has a circular or round appearance to it. And if you notice, it has this very white interface. And this has what's called a very high epigenicity. And notice behind it, you can't see anything behind it. None of the ultrasonic waves will penetrate behind or deeper to the bone. They're all reflected back or scattered from the bone surface. And so that is how you can identify a bone structure, right? That's one of the key features. And bone is among the easiest to identify. Now, right next to it, over here, you see a couple of structures. This pulsating structure here is an artery. It's not a vein. I can tell you it's not a vein because when we put pressure on the probe here, we compress away the veins, and the veins disappear. So we don't see them when you're doing the ultrasound. And I only know that it's an artery at this point because of its pulsating nature. If I was not clear whether that was an artery or not, I wanted to see if I could turn on the Doppler here and position it, and you can see there's blood flow through that structure, and there's no blood through any other structures in that image right there. And so that is an artery. The fact that it's blue doesn't mean anything. It's just the direction of the flow. If I flip the probe over, it would be red. So the color doesn't have any significance or any indication. I'll turn that off. And then so right here, this is a bone window interface here. This is a bone interface. This is a bone interface. And you can see behind all of those interfaces, it's nothing but black scan because there's no penetration behind that. But this right here is the carpal tunnel. This structure right here. And within that carpal tunnel, you see a lot of structures. I've already pointed out the artery. But the rest of these are nerve and tendons. And the question is, how do you know whether it's a nerve or whether it's a tendon? Well, this is the benefit of having a dynamic procedure. Because if I can take this probe, I'm holding it nice and steady now, but if I rock it, you'll see the image starts to change. It changes its look. And that change is resulting by the scatter of the ultrasonic waves, by the direction that they're being emitted to the probe and the angle in which they're hitting the tissue and bouncing off. And this is something called anisotropy. And if something has a high degree of anisotropy, that means that it changes its image a lot based on how I rock it. If it has low anisotropy, it means it doesn't change when I rock it. The grayness, the blackness stays the same. So just look at this artery again, right here. And watch as I rock the probe. Stays black, stays black, stays black, stays black. That has very low anisotropy, and so that's another indication that tells me that that is an artery. All right, look at this structure right here. Look at these: white, black, white, black, white, black. That has a very high anisotropy, and that is a characteristic feature of tendons. So I know that all of these structures in here are tendons. But look at this structure right here. This structure here. So here it's grayish. It's not black, it's not white, it's grayish. If I rock down, it's a little more dark. It's a little more white. But it doesn't change anywhere near this tendon right below it changes. So this has an intermediate anisotropy, and that's characteristic of nerve. So I know now that this is the nerve, and I know in particular this is the median. If I go back over here by this artery, back to the pisiform bone, I'll get myself oriented here. Here's the pisiform bone right there. Here's that artery again. And this structure right here is, if I rock it, it has an intermediate anisotropy. So this structure right here is the ulnar nerve. And so here's the retinaculum and the carpal tunnel right here over the top. So in doing that, you can easily identify nerve, tendon, bone, artery, and the one structure I haven't shown you is muscle. So we're going to, there usually is no muscle within the carpal tunnel, so we're going to go up into the forearm. So now